Hi, I'm John. In this project, we explore the principle of electromagnetism through two important physical phenomena, the Hall effect and the Doppler effect. The Hall effect allows us to detect magnetic fields and determine their polarities using sensor connected to the simple circuit with resistor and LED. It helps us to visualize how magnetic interaction can produce digital signals. On the other hand, the Doppler effect helps us understand how the frequency of wave change when the source is moving. By combining the two effects, our project connected theoretic concept in the electromagnetism with the application.
So let's take a look for explanation circuit. So this is our schematic circuit for our project Doppler effect. We're using four component electric, Hall sensor, resistor, LED, and Arduino. Okay, the first one is Hall sensor. For this project, we're using a digital Hall sensor A3144. Function of Hall sensor to the circuit is to detect the magnetic field. So the outputs of voltage is depending on the presence and strength of a magnetic field nearby. So when we put the magnet near to the Hall sensor, it can detect the magnetic field. Yes, it can detect the magnetic field. The next component is resistor. Uh, we're using a 100k ohm resistor as a pull down, as a pull up and pull down for the Hall sensor and LED. So the 100 kilo ohm, it going from the output pin connected to 5 volts Arduino. Then the LED. The function of LED in this schematic circuit is to light up to indicate the presence of a magnetic field. It based on sensor output. So when the LED lights up, eh, when no, the LED lights up when the magnet nearby by sensor. Otherwise, it will turn off. Alright, so let's take a look for coding from Arduino for our project. So the first one is to set up the digital sensor. We're using a so the digital hall so the hall sensor is connected to Arduino pin number 4, and then the LED connected to Arduino pin number 2, and then void setup to set the pin modes. So for hall sensor we set the for input and the LED for output. Hall sensor is input because we the hall sensor is function is to detect the magnetic field, and then when the hall sensor is detect the magnetic field, the LED will lights up. Okay, and then void loop to read the sensor values. So to read the hall sensor to detect the magnetic field, and then the hall sensor is set for high when the magnet is nearby, and then the LED will set to high, so it's become on. The LED will turn on. Otherwise, if the hall sensor is not detected the magnetic nearby, the LED will turn off.
Good day, everyone. Today I'm going to explain about the observation that we got from our projects. So, in this slide, we will explain about the North Pole reaction to the LED on or off. So, when we place the North Pole of the magnet at the back side of the sensor, which is the flat side of the sensor, the LED will turn on. But when we move the magnet to the front, which is the curved side of the sensor, the LED will turn off. And this is shows that the sensor detect the north pole more strongly at the back and stop detecting when we move to the front. So the sensor actually give a digital signal to Arduino, and the LED will lights up and off based on that signal. So for this slide, we run a test for the south pole side of the magnet, and we notice that the result turns out to be the opposite from the north pole. The LED will turn on when we put the magnet to the front side of the sensor, and the LED will turn off when we put the magnet to the back side of the sensor, which means the sensor can detect magnetic polarity and give a different output depending on the direction. So this reaction is based on the Hall effect, where the sensor sense the magnetic field and give an on or off signal. This is very useful for simulating heartbeat motion, like in a Doppler fetal monitor.
Assalamualaikum, I am Saila. Now I will conclude all of our project. It is successfully demonstrate of a Hall sensor, resistor and LED. The behavior of the LED is turning on and off depending on the magnetic pole. This clearly shows how the sensor responds to polarity and how digital signals can be used to represent this change. Additionally, we explore the Doppler effect through practical observation, helping us understand how motion affects wave frequency. Overall, this project not only strengthened our understanding of electromagnetic principles, but also allowed us to apply them in real-life simulations, such as detecting motion similar to a heartbeat using magnetic interactions. That's all from us. Thank you.